In this video, we're going to use the law of sines to solve applied problems. And as a quick reminder, the law of sines says that for a triangle with sides ABC and opposite angles ABC respectively, that sine of angle A divided by side A equals sine of angle B divided by side B, which equals sine of angle C divided by side C. In addition, we'll use the fact that sum of angles of any triangle equals 180 degrees. In this example, let's consider the geometry inherent in a combustion engine. The problem states, on a certain automobile, the crankshaft is 4 inches long and the connecting rod is 8 inches long. At the time when angle OPR is 21 degrees, how far is the piston, located at point P, from the center of the crankshaft, located at point O? In this image, we have a piston located at point P that lies on the positive x-axis with coordinates x, 0. A bar of metal, called the connecting rod, connects the piston to the crankshaft at point R that lies on a circle of radius 4. As the piston moves back and forth along the x-axis, the point R, where the connecting rod is bolted to the crankshaft, rotates counterclockwise in a circular motion. And this circular rotation is centered at the origin of our coordinate plane that we've labeled as point O. And we can draw a triangle on this diagram where the bottom leg represents the distance of the piston from the center of the crankshaft circular rotation. On our diagram, that is line segment OP. A second leg of the triangle represents the connecting rod, and this is line segment RP on our diagram. And the third leg represents the radius of the circular motion, and that is line segment OR. We've also labeled an angle theta between the connecting rod and the x-axis, and that is angle OPR in our diagram. Now again, this problem asks us to find the distance the piston is from the center of the crankshaft when the crankshaft is 4 inches long, the connecting rod is 8 inches long, and angle OPR is 21 degrees. Now let's convert our diagram and use the standard labels of A, B, and C for sides and angles. So we begin by drawing a triangle with a horizontal side of length C that represents the value of the x-coordinate of point P. This is the length of the line segment OP that we're being asked to calculate. Also on the triangle, label line segment OR as side A, which has a length of 4 inches, and label line segment RP as side B, which has a length of 8 inches. Angle OPR has measure 21 degrees and is opposite side A, so let's denote it angle A. And finally, angle ROP is opposite side B, so let's label it angle B. Since we know angle A is 21 degrees, we know side A equals 4 and side B equals 8, then we can use the law of sines to find angle B. Therefore, we can write that the sine of 21 degrees divided by 4 equals sine of angle B divided by 8. Solving for angle B, we get that B equals inverse sine of 2 times sine of 21 degrees, and that's approximately 45.8 degrees. Now let's notice in this diagram that point R is in quadrant 2. In that case, we need the obtuse angle for angle B. Now, it could also be the case that angle B is in quadrant 1. Now let's first solve this triangle for the case of the acute angle B, where point R is in quadrant 1. Then we will come back and solve for the obtuse angle with point R in quadrant 2. So now let's find side C. We need to calculate angle C first. Therefore, angle C is approximately 180 degrees minus angle B minus angle A, and that's 113.2 degrees. Finally, we can use the law of sines to find side C using angle C we just found. Angle A equals 21 degrees and side A equals 4. So we can write sine of 21 degrees divided by 4 equals sine of 113.2 degrees divided by side C. Solving for side C, we get C equals 4 times sine of 113.2 degrees divided by sine of 21 degrees, and that's approximately 10.26 inches. Now let's come back and find how far the piston is from the center of the crankshaft for point R being in quadrant 2. So again, earlier we found the acute angle B to be approximately 45.8 degrees for R being in quadrant 1. So the obtuse angle, let's call it angle B sub 2. That's going to be the supplement of 45.8 degrees. So angle B sub 2 is equal to 180 degrees minus 45.8 degrees, and that's 134.2 degrees. So now we're going to find side C, which we need to calculate angle C. So angle C is approximately 180 degrees minus angle B sub 2 minus angle A, and that's 24.8 degrees. Now we can use the law of sines to find side C using angle C we just found. Angle A equals 21 degrees and side A equals 4 inches. And we can write sine of 21 degrees divided by 4 equals sine of 24.8 degrees divided by side C. Solving for C, we get C equals 4 times sine of 24.8 degrees divided by sine of 21 degrees, and that's approximately 4.68 inches. So we have found two distances that the piston can be from the center of the crankshaft for when angle OPR is 21 degrees. Now physically speaking, we could have point R be in quadrant 4, which would produce the same distance for the piston as point R being in quadrant 1, and that was a length of 10.26 inches. And also note point R could be in quadrant 3, which again would be the same distance as for point R being in quadrant 2, and that was 4.68 inches. In this example, let's consider a scenario where we need to transport a passenger to land. The problem states that a cruise ship is docked at their private island. A passenger has become very ill and needs to be flown by helicopter to the nearest hospital. There are two hospitals on the coast of the mainland that are 50 miles apart. Now, the bearing from the ship to hospital A is south 20 degrees east, and the bearing from the ship to hospital B is south 73 degrees west. Part A asks, how far is the ship from each hospital? Well, let's first sketch a diagram to visualize this scenario. We're going to draw a triangle with vertices A, B, and C. Now, vertex C represents the location of the cruise ship, while points A and B represent the hospitals A and B respectively. A line segment BA is the horizontal leg representing the distance between the two hospitals. And we could drop a vertical line from point C that represents the south line, and it connects to line segment BA at point T, forming a right angle. Now, since the bearing from the ship to the hospital A is south 20 degrees east, then angle TCA is 20 degrees. And similarly, since the bearing from the ship to hospital B is south 73 degrees west, then angle TCB is 73 degrees. Well, let's find angles A, B, and C. Now, angle A is inside of triangle ATC. Angle ATC is 90 degrees and angle TCA is 20 degrees. Therefore, angle TAC, which is our angle A, will be 180 degrees minus 90 degrees minus 20 degrees, which is 70 degrees. Angle B is inside of triangle BTC. Angle BTC is 90 degrees and angle TCB is 73 degrees. Therefore, angle TBC, which is angle B, will be 180 degrees minus 90 degrees minus 73 degrees, which equals 17 degrees. Finally, let's note that angle ACB, which we will call angle C, is 73 degrees plus 20 degrees, and that's 93 degrees. So now that we have the three angles, let's note that side C is given in the problem as 50 miles. Part A asks us to find the distance from the ship to each hospital. So we need to find the measure of side A and side B. First, let's find side A. Using the law of sines with angle C, side C, and angle A, we can write sine of 93 degrees divided by 50 equals sine of 70 degrees divided by side A. Solving for side A, we have A equals 50 times sine of 70 degrees, all divided by sine of 93 degrees. and that is approximately 47.0 miles. Now let's find side B. So using the law of sines with angle C, side C, and angle B, we can write sine of 93 degrees divided by 50 is equal to sine of 17 degrees divided by side B. As solving for side B, we have B is equal to 50 times sine of 17 degrees, all divided by sine of 93 degrees, and that is approximately 14.6 miles. Therefore, the distance from the ship to Hospital A is approximately 14.6 miles, and the distance from the ship to Hospital B is approximately 47 miles. Part B of this problem says, if a helicopter can fly at a speed of 150 miles per hour, how long will it take to reach the nearest hospital? So we know that the equation rate equals distance divided by time represents the relationship between those three quantities. And intuitively, we know that this is true when we think of speed in units such as miles per hour, which represents distance over time. So we can take this equation and we can solve for time, and we can write that time equals distance divided by rate. So let's use this equation to find the time it will take for the helicopter to travel to the nearest hospital. So we had found the distance to the closest hospital to be 14.6 miles. Therefore, the time that it's going to take for the helicopter to reach that hospital is 14.6 miles divided by 150 miles per hour, and that's approximately 0.097 hours. We know that there are 60 minutes in 1 hour. So multiplying by 60, we get 5.84 minutes it takes for the helicopter to fly to the nearest hospital.